Helps if I turn on the mic. Hey everyone. Thanks for joining and thanks for sticking with me starting a little late. I'm figuring out what it's like to stream at nighttime, and I do not have my timing on par. Figuring out how to make dinner and take out the dog, sorting all of that out. So I'm still getting settled, but I'm glad we've got a couple people here. Say hey if you're in the chat. And I'm gonna slowly get myself set up, and somehow after cleaning my desk like a week ago, I've already made it terribly messy. But hopefully today we'll do a little bit more programming. Yesterday was a lot more triage. Spent a little bit longer than I meant to triaging, but I think it was a good thing because, to be honest, triage needed to happen. I have so many boxes of dev boards. Let me find the one that I am looking for. I am looking for a very specific board. I'm looking for my Decawave board. Oh goodness. Let me pull up. Hey Ethan. I know I had one of these because I pulled it out earlier today to look at it because I wanted to test something. And I put it back. I swore I put it back. That's okay. Let's see, do I want to just use... Oh, I can use this one. Here's one. Ugh. So I'm going to be playing with more of the... Well, I'm going to start working on the extended shock burst stuff. I had a conversation with Talis after the stream yesterday, and he and I had some conversations about switching over. Right now he's using Heapless, and there was going to be some plan to play with getting BBQueue in there. Goodness. So I think I'm going to do that first, at least to warm up. And when I say warm up, I mean I might spend all of my time playing with BBQueue, but hey, that's how that goes. Let's see, I've got a USB cable, and I've got a USB cable, and I've got a board, so that should be all I need for now. You know what I should do? I should go pull up chat and see. Let's pull up the Matrix chat. If you don't hang out in the Matrix room, I would recommend it. It's a pretty sweet room. There's a lot of people in there. They're very helpful. But I'm going to go spam my stream in there. Excuse me. So I have a board. I think that's all I need to get started. Let me pull up my office hours repo. So quick reminder, for everything that I'm doing here, I've got a tracking repo, and it's actually been super nice. I've started putting like all the stuff that I've been meaning to do in there, so it's kind of become my own task tracker. But yeah, you're welcome to suggest more things here or comment on things, tell me if they're a silly idea. But yeah, so as a reminder, well, you're already watching, but yeah, the channel's here. I'd appreciate a subscribe. I'm trying to get to 100 so I can have a custom channel on this new stream. I have one on my old stream, but not the new one because this one's brand new. But if you subscribe there, I would appreciate it. Everything's in the notebook, so let's go to today's notebook item. So yeah, I'm going to play more with Talis Fregoso's repo where he started working on this. I've got links to the docs. I may end up writing the RFC. We'll see. Maybe I'll do this on camera. Maybe I'll do it off camera. But yeah. Where would I find the Matrix room? Let me link to that. I should probably put this in. Let me open up an issue to myself. That's just link to the Matrix chat in the README. there's a more useful matrix.tl. Actually, you know what? I'm just going to do this because it's easier than opening up an issue. So let's go in here, readme. Let's see. I also usually hang out in the Rust embedded matrix chat. Feel free to comment there or in the YouTube chat for each stream. I'm James Munns, matrix.org. Okay. Let's just add this so I don't forget about it. Cool. So now it's there. So now if you aren't able to click that link in the chat, then that's okay. The one I linked is the RightIM. I use the web browser for that. But you're welcome to use whatever client you'd like. You can't see it, but I'm sorting out my tiling window manager because I've done something terrible here. Okay, cool. La-dee-da. So hey, I've got 10, 11 people here. That's pretty cool. Okay, so yeah, I was going through. What did I do? Oh, I got rid of my Firefox window. Huh. Let's bring that back. Okay, actually, you know what? This is me unable to juggle things. What was I gonna bring? Office hours. Is anyone in the chat working on something interesting now? 4. Okay, here we go. So yeah. Today's notes, they actually weren't that interesting because there wasn't much new. But yeah, I'm gonna go check out Teles Fregosos. So I already have this clone. So let's go up to ESB, pull origin master because I think he did some work on it yesterday. And let's do a git fetch. See if he has any interesting branches. Nope, no new interesting branches. So he's got some stuff, but that's good. Let's open up a new window just so Rust Analyzer kicks in. So there's all kinds of there's probably a way. Let's default $52,840. So let's give it a default just so Rust Analyzer will be happy. Because let's be honest, I'm probably only going to support this for the 840 for now. Well, actually, no, that's a lie. I am working on the 832 because the Deckwave board is an 832. So we're going to start working on that. I think the first plan, just to warm up because I could use it, is to switch over to this. So actually I wanted to go and look at what the interface is here because there's kind of like two parts. There's the why can you not find radio? You're pulling in the 832. I've managed to make Rust Analyzer very sad. Well, now it seems to be figuring things out. I want to see what the interface is. So you make a new TX buff. what is going on with all this buffer stuff? So where do you come from? Buffer. Use packet buffer. Okay. Packet buffer is a generic array. Type to be used by the ESB stack to perform radio transfers. Okay. I think we're going to get rid of that, but that's cool. Okay. And radio. See, it's still not finding radio. That's weird. Oh, maybe that's why. So this is from the 3G. I'm surprised we don't export this. We should probably export that, but that's probably why it's there. Okay, yeah, the goal so what's going on? Let me actually, you know what? Let me do this in Can I drag this over? No, that's not going to work. Let's just wiggle this all around. Okay, so this is today's notes. Stream notes. So what are we doing here? So what's going on is you have, like, even within one library, you've got kind of two parts. Because this the whole radio stuff needs to be done in a pretty high priority, like, interrupt context. So you've got two contexts. We've got interrupt context, and we've got app context. And as a reminder, in embedded Rust, we typically treat interrupt context, like each different interrupt context, and like your main application, as separate threads. So if you're used to developing Rust off of embedded systems, you can think about that. They're a little different than threads in that they never really run concurrently. You're always only ever running one or the other. Yeah. But they still sort of need to be thread safe because they can preempt each other, which means when you're communicating between the two of them, you need a something that is thread safe. Additionally, that's not a word. What did I do? Nope. Additionally, we are going to be doing DMA, which means we need to have packets in RAM, because on the NRF52 specific, the DMA engine on the NRF52 only supports DMAing things out of RAM, which means if you had like a constant packet that was stored in flash, you couldn't DMA from that. Which is somewhat annoying because it doesn't throw a fault and you won't get any compile time warning. But that's why you have all of these like checks we have here, like in slice in RAM. These are just checks to make sure that you're between the SRAM ranges. Yeah, so Talis he's I keep ducking over here. I don't know if he's watching the stream, but he's sending me notes. I'm on stream now. Let me know if you plan to watch. Otherwise, I'll work on BBQueue and the user interface. It's probably really weird if he is watching because he's hearing me narrate my messages to him in real time, but then it's a race to see which has more delay, Matrix or the chat. And he's typing. He's probably going to say I'm watching. I saw you have no standard in your crate. Is it also no Alex? So Zishan, that's a good question. Yeah, almost all of the embedded stuff I do is no standard and no alloc. So it's totally no standard. Most embedded systems don't have an allocator, and primary reason for that is because it's not stable to build. Like you can't declare, you can't make an allocator in Rust stably today. You can use a global alloc, but I think it's the out of memory error or something like that. That interface is unstable, which means I'd have to be on nightly. So most people are. So Sishan's also asking what heapless is. Heapless is a crate for doing. Actually, let me go through this because this is probably useful to a lot of people. Okay, so because we don't have an allocator, but we still want sort of dynamic behavior, there is stuff like oh no, I'm messing with tabs. There is r/heapless. Actually, I'm gonna change a setting here real quick because I need to set up a separate profile for streaming so that I don't share work stuff, because I have my Firefox set up to conveniently search across all my computers. So let's get rid of auto completions because we don't need that. Okay, so that's nice and clear. So yeah, heapless is a library where you can build structures that have a fixed maximum size. So you could have a vec that has a max of 50 elements, and you can make that static, or you can make it on the stack or wherever you'd like it, and it'll start empty, and you can push stuff to it. But you can only push stuff to it until there are a max of 50 items on there. This is a nice way to work around not having an allocator. It's kind of like a slab allocator if you've used C++ or something like that, or a pool allocator, where you have like a max number of items. And heapless is a really nice crate by Jorge or Japarek, and it's got a bunch of stuff. It's got like a binary heap. Pool is used a lot. String, vec, SPSQ I use a lot, and that's what Tallis is using in his code here. And it's basically like a thread-safe single producer, single consumer queue. It's generic over its size, so it uses generic array to kind of simulate const generic types. And it's a really handy crate. I use it a ton all over the place. It's a nice workaround for not actually having a heap allocator, or even if you did have a heap allocator and you wanted your code to be a little bit more deterministic, you don't want garbage collection or you don't want something like that. So yeah, it's really similar to the ArrayVec crate, except for ArrayVec will fall back to allocating if it runs out of room. Like if you hit the threshold, it has a threshold of like 8 or 16 items or something like that. And the first 16 items you push, it will push on the stack. But then when you go over that, then it will do a dynamic allocation. Heapless will never. If you try and push more than it has room for, then your allocation will just fail. It actually returns a result. But actually, I have nothing but good things to say about heapless, except that I've written a crate called BBQueue, which is meant to be used in a similar kind of use case. But BBQueue is really good for streams of data, and particularly streams of data where you have like components that are variably sized. So the way heapless works is where are my notes? Let's do quick primer on heapless and BBQueue. If you had a heapless that let you, this is not the right syntax, but let's say 0U8, you had 32 bytes, and you can have 10 of them. So you'd have something like this. And what that's going to do is it's actually going to be 320 bytes. So it's going to be like 10 arrays of so Jonas is saying, or am I thinking of small vec? I actually don't know the difference between array vec and small vec. So one of them does like heap allocations later, but I think Jonas is right. I think it's small vec. So heapless will actually put like 32 bytes and then 32 bytes, and then whatever until the last 32 bytes. So there's a total of 10 of them. And this is great. If all of your messages, or if you had a struct that was a fixed size and you wanted 10 of them, it's perfect for that. You should definitely use, excuse me, this is heapless queue. You should definitely use heapless, because heapless is a very good library. But if you have something like variable packets, like for example, if you're receiving a radio and sometimes it could be 2 bytes and sometimes it could be 12 bytes and sometimes it could be 64 bytes and things like that, you'd have to make it at least the size of your biggest packet. So for shock burst, the largest message is actually 257 bytes with header and stuff like that. Which means if some of your messages were 10 bytes and some of them were 257, if you wanted to have a queue of 10 of them, you'd have to have 2,570 bytes. And then if you got like 10 messages in a row that were each 5 bytes, you'd be wasting like all of those 2,000 bytes. BBQueue lets you make one big pool of bytes that you can then chop up into variably sized pieces. So you can have like kind of a big one and a small one and a medium one and a big one. And I have a whole separate stream on my old channel about how this works in more detail. But the cool thing about BBQueue is when you get a chunk of bytes, they're always going to be in a row. So you can always have like one slice that's continuous. And you can have ones of different sizes. So that's the TLDR. BBQueue is really great for variable size, I'm going to say chunks of U8s. Heapless, you could do this as an array, but you could also have like some struct and you could have 10 of them in a row. BBQueue will only give you just a pool of bytes, so it's always like U8s. You could do something similar with like heapless pool, but that has the same problem, is that each chunk of the pool always has exactly the same size. So we're actually going to use this because we want to support variable length packets for ESB. And the other important thing is that, like I said, we're going to be doing DMA. So we want to be able to have like, you know, variable size chunks that we can commit. And BBQueue also lets you do things like you can start with getting like a big chunk. I need another symbol that isn't. So you can start with saying, okay, I want to reserve all this space. But then later, if you realize you only need this much space, then you can free up this space to be used for something else. So you can decide later that you didn't want to use all the bytes that you originally asked for, which is nice because what you'll probably do when you're receiving a packet off the radio is you'll ask for the maximum size of a packet, like 257 bytes. And then once you actually receive the packet and you go, oh, this was only 12 bytes, then you go, okay, cool, I'm going to free up my next 12 bytes. Cool. But yeah, so we're going to go ahead and use that. Yeah, but the reason that we're doing all of this is because it needs to be in RAM, which is NR specific, and data must be contiguous. Data must be contiguous because DMA. So DMA means that your hardware is going to go and copy bytes for you. So instead of sitting there and going byte, 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 and copying them from one side to another, you just say, start here, go for the next 200 bytes, let me know when you're done. And the hardware will copy them for you. Sometimes it copies it from memory to memory. Sometimes it copies it from memory to hardware. So in this case, like, you could say, hey, radio, here's a chunk of bytes. Let me know when you receive a packet. And you receive a packet, and then it says, I just put 12 bytes in memory for you. Enjoy. And the hardware did it all automatically without the software having to get in there. BBQueue is exactly designed for doing DMA with. Like, it's literally why I designed BBQueue, was to do DMA with. So that's enough of a quick primer. Yeah, and then the comms between contexts must be thread safe because interrupts. So what is our interface going to look like? So we have like two sides. We've got our app side, and let's say this is a well, I guess it doesn't actually matter. We've got our app side, and we've got our interrupt side. So from our app side, we want some handle. So we want like some structure that represents the radio. It should be able to send a packet, and it should be able to receive a packet. And on the interrupt side, you should be able to say, something like, so this is going to also have some handle. People are asking questions in Matrix. Is there an elegant solution in Rust to create an integer to be used as a bit mask with the n lowest bit set to 1? And see, I'd use something along the line of 1 shift n -1. Yeah, that's probably what I would do, honestly. You want to have some handle, so you can like give some handle to the IRQ side. And you want to be able to get outgoing packet, and you want to be able to shove incoming packet into the queue. So actually we have two things here. We have data going this way. This is probably too many. We have data going this way, outgoing, and we have data coming this way, which is incoming. And each of these are actually going to have different sides, where the outgoing will have a producer and a consumer. So you can see like one half of this equation is producing messages and one half is consuming it. And for incoming, we have it the other way around. We have the application is going to be the consumer over here, and it's going to be the producer over here. And this tells me we need 2 BBQs. So I want to end up having some kind of interface that's something like, one of my favorite things to do is to write fake code. So I want to be able to do something like, and because I want this memory, this is another thing we need. Data must have static lifetime, mostly. So because the interrupt, DMA is hard, because DMA doesn't really respect Rust's lifetime, because one's a hardware concept and one's a programming language concept. So the only blanket safe way to do this would be to have something in the static lifetime where these queues live forever. So even if the DMA kept going, it's fine. It's just going to keep overwriting memory that no one else knows about. So we want to have something like static buffer equals, I don't know what type it's going to be, equals something like ESB buffer new or something like that. And because this is, let's have an ESB buffer, the outgoing size and the incoming size, something like that. Let's bounce around and make sure I'm not missing anything, not missing chat or anything. No, cool. Yeah, Jonas is suggesting the same thing that I am. So yeah, so this is a buffer for ESB. Incoming queue is 512 bytes. Let's make it 1024 is 1024 bytes. Outgoing queue is 512 bytes. So that's where I get these numbers from. So I create a new one. And then I'm going to have something like function main. And I'm going to have, let's see, let's see, app ESB, IRQ ESB equals, let's see, ESB interface new, and we'll give it buffer dot unwrap or something like that. So then we'll have our two handles. We've got the app side and the IRQ side, and then we'll do something like somehow send IRQ ESB to the interrupt. So let's pretend we've moved that. I know how I'm going to do that. I just don't explain that now. So we've now given the interrupt half to the other side. We may end up needing something like radio. Well, no, I guess maybe we can do that from the app ESB. So then we probably want to like start this is probably going to be mutable. We're probably going to do something like start the reception process or something like that. So we probably want to do something like let mute message equals something like app esb dot start send dot unwrap. Well, let's, I don't know, enable ESB or something. App ESB dot I don't know. We're gonna have something in here. Are you complaining about my spelling? Okay. Let's turn off. I always screw up the key combination for sort all lines and spell check. So sometimes I try and spell check and it just sorts my entire file alphabetically, which is not particularly useful for notes. Start the reception process. So we have a message, so then we can like fill the outgoing message. Message dot, I don't know, message, I can't type, dot copy from slice, I don't know, I'll say like message, let's pretend this is a slice or something like that, dot dot the first 8 bytes or something like that, 10U8 8, so we're just going to fill it full of the number 10 for some reason, and then like message dot complete send or something like that. And then we're going to, so I'm doing this because I know that I'm going to want to make a 0 copy interface for the radio, just so you can like, if you were filling data, you could like get the next message, copy data into it, and then send it out instead of having to like make a mem copy of this. So this is why there's this like 2-stage this, and if you look at BBQueue, this is exactly how BBQueue works. Then let's like wait for an incoming message. Maybe we do something like while let okay none equals app esb dot get message. I don't know, we'll just wait. So now we're not waiting. Actually, this probably won't work because I need an else case there. I don't know. Well, not. I'm imagining things. Message ready or something like that. Waiting, and then we do something like let incoming equals app esb.get incoming cert eq. Let's say everyone responded with 11U8, 8. So we expect to get a fixed size message back and that. So like this is what we kind of want our interface to look like. You got the side the app's going to handle. You've got the side that the interrupt's going to handle. Sorry, I'm getting work emails. Problem with with having clients in the US is that they email you at weird hours. Okay. Well, it's not weird hours for them. I'm sure in California it's a very reasonable time right now. Okay, and then we're going to do something on the other side. So we're going to have something like interrupt radio or something like that. Let ESB handle equals, I don't know, get something get dot unwrap. I'm not going to deal with this now. I'm probably going to use something like the CMIM crate or Jonas's IRQ crate, which are both really useful. Or actually, I'm probably just going to use RTFM for this. And RTFM makes it really easy to send stuff, to give data to an interrupt. But I'm not going to get into that yet. I don't know what I'm going to do on this side. This is like something with the radio? Question mark? And then probably like note, this pens the radio interrupt too. So we probably like, this was probably going to kick the radio. I'm writing all this down. I'm just writing out what I think this interface needs to look like. And then I'm going to go look at Talus's code, and I have no idea what it's going to look like. So we'll find out. Maybe it'll be aligned. Maybe it won't be aligned. We'll see. We'll probably have something like static mute state or something like that equals, I don't know. And we'll probably do something like match state. If it's idle, maybe we like maybe check for outgoing, check for incoming. I don't know. If we're like state waiting for ACK, I guess the only time we'd be waiting for incoming would be the waiting for ACK. So I guess idle would just be check for outgoing. Huh. Well, apparently if you're in the IRC mirror of the Freenode channel, then weird. I don't know if anyone else is looking at Matrix, but weird messages. What? Yeah. I guess if we're idle, we're going to be checking for outgoing, waiting for ACK, check for incoming. I guess if we're waiting for incoming, maybe also a new outgoing. And then maybe if got ack, I don't know, push into queue, and then check for next or something like that. I don't know. We'll see. We'll find out. This is going to be more of Talas's code. I'm actually going to lean on his code for what the radio does. I think he's also working on that still. Yeah, someone wrote, like, who said, I guess, that they were Freenode staff, is just like, we want to make sure that there's no bots in here, and then just ended with obscenity. So yeah, I don't know. Weird. Okay. Oh, and if anything that I'm saying up here isn't making sense, let me know, because I'm like thinking things out, and I don't know, I could be either not explaining myself well or making an entirely huge mistake. So yeah, if I'm ever saying something that doesn't make sense or you don't know what I'm talking about, then just let me know. But this is roughly the interface that I'm going for, and that was the important part that I wanted to explore. So that's enough of that. Let's go back again and look at how this works. So I think there's like there's a consumer and a producer. So right now he's doing sort of this, only it's with a heapless queue instead of a BBQueue. So really, ideally, I should just move it over there. So we're going to do this a little differently because BBQueue does have this two-stage thing going on. So I'm going to end up getting rid of this because we're not going to have like a fixed. So the problem with using like heapless is you have to have the fixed buffer that actually lives in there. We're going to get a little tricky with the interface here and provide a wrapper around this. This is interesting that it's we should probably make this a builder pattern because these are gnarly to use, but I will by the way, AJM are my initials, so I go by James, but James is my middle name. My first name's Anthony. But yeah, I go by James. But if you ever see me making comments and they say AJM, that's where the A comes from. Move to a builder pattern here. Just noticing stuff as I go by. Type to be used by the ESB stack to perform radio transfers. Okay. Where does buffer get used? References. Okay. So he's like taking it out of the queue and putting it in the radio, and like he has like one active buffer in there maybe? Okay, and he's doing that so you can hand in the buffers. That makes sense, because then this is his limitation, that you need to have a static buffer so that the lifetime always checks out, so the DMA can't go wrong. But I think I can simplify a lot of this, which is good. Yeah. Okay. Tell you what. I'm gonna be back in a minute and like less than 5 minute break, and then I'll be back and I'm gonna start actually digging into code. I've done as much thinking. Now it's no more time for thinking, just for coding. So I will be back in a minute or two, or like 4 or 5 minutes, and we'll get started with actually writing code. I promise on one of these streams I will write some code. All right, be back in a minute.
into one.
The point was at this time that when I did that, we were speaking about that nothing is really corny if you can find a way to do it.
So I switch from cut to fade. Yeah, that's much better. Okay, so I was chatting with Talis a little bit. Okay, so yeah, we got some surgery to do. Okay, let's go ahead and let's pull in BBQueue and let's start chopping. Okay, so we're gonna have, excuse me, and this returns a self. So ESB radio new static buffer. So where does the actual radio side go? Okay, ESB radio. Apart from the payload itself, we need to know the PID pipe. Okay. Tell us to figure out how much delay we have. So when I snap, I'm going to hit the send button on Matrix, but Matrix has lag too. So send. That went pretty quick. So, okay, just to figure out how much lag there is between the stream and that. Okay, so where does the actual radio go? So the radio goes in here. The radio gets given to the ESB radio. The ESB radio, where do you live? ESB radio. Peripherals, ESB radio. Radio with buffers, cool. .init. Oh, okay, so I guess you don't actually... It's like 5 seconds. Okay, that's not bad. So tell us, have you actually gotten to the part where, like, how does the interrupt actually get the ESB radio, or have you not sorted that out yet? Because I don't see how you're actually getting the half that has the that you give to the that you give to the actual interrupt, because the ESB looks like everything. Is there like an ESB split or something like that? We got some logging. Okay, we got a packet. Okay, peripherals. Okay, I'm guessing you don't have one yet. So let's just make a new file for now that I'm going to put some stuff in. We would call esb.update on the radio. But is the ESB global or something like that? Are you planning on putting it behind like a mutex or something? Or like, check out Rubble example. I think I will do something similar. Well, let me propose to you something different. Let me know what you think of this interface, because I kind of like this interface, but I can also look at Rubble. All right, you know what? I will listen. I will delay coding again. So Jonas, who at least at some point was in the chat, is... Let me look at the example. Demos. 52 demo. Source. What do you do? Main. We do a config. That's interesting. BBQueue app config. Okay, so that's packet. Okay, so who uses the radio in here? Create the queue. Okay, but I want to know radio context, resources, radio. Okay. So blue radio. Yeah, so Jonas is doing something really similar to what I thought. It's not being shared. I think I'm just either not seeing the code or the code doesn't exist over here yet. That's okay. Either way, we would need PPI to transfer the timer interrupt to the radio. I don't follow. So I'm going to do this blindly, and you're probably going to tell me that I'm wrong, but I want to write some code. So I'd rather write some wrong code right now. So I guess I'm going to hack on this for a little bit, and we'll see if Talus tells me that I'm totally, totally wrong. Okay, so I'm going to have in lib. Let's go ahead and tell it that mod James. So we're going to have two parts. Let's go back and look at my code. We're going to have two things. We're going to have an ESB buffer, which is going to have some stuff in it. We're going to have a pub struct ESB app. Don't worry about the names. They'll get better, I promise. ESB IRQ. Stuff for the interrupt side of things. This is like BLE radio. Also, Jonas, if you're in the chat and you want to yell at me and I'm obviously not doing the right thing, let me know. Stuff for the application side of things. I don't actually know what this half does. And the ESB is going to be const, and what I'm going to have in here is what we're going to have in here is we're going to have app to radio buff, which is going to be a BB buffer, and I'm going to start needing pulling things. Use BBQueue buffer. I'm going to need the producer. I'm going to need the consumer. I'm going to need const. Yeah, that's fine. You're gonna be I know I'm gonna screw up like the ordering of outgoing and incoming. That's what I need. I need array length. And this is all to get around the fact that const generics are not stable. So there's this wonderful crate called generic array, which takes care of this for us, but oh, you're right. I'm going to use not BBQueue. You're right. I'm going to use the framed version. Frame consumer, frame producer. Okay. Outgoing length, and then radio to app buff is going to be a BB buffer. Incoming len. Probably some more stuff, maybe. I don't know. We'll see. Let's make these pub because I don't want to deal with constructors right now because they're going to be const and they're going to be terrible. Um, so framed is a new mode that I added to BBQueue recently that lets you do those like chunked version of things. Like I said, if you're interested, I have a yeah, I guess this doesn't actually need a cons. So what is it gonna have? It's gonna have like the app is gonna have outgoing. Prod is gonna be a frame producer. And I need to copy all this. Getting distracted by notifications. That's okay. Okay. Missing lifetime specifier. We're gonna pretend everything's static right now. ESB IRQ is gonna have something like frame producer, and this is where it's gonna get complicated because everything's backwards. Incoming len. Cons from radio. I'm making these names super long and like too long because it will keep me from screwing myself up later. Static outgoing len. Upper camel case name. See, why do you... I sort of disagree. I kind of like... Oh, well. Okay, so I got the two halves. I know I'm going to need some more stuff in there. I don't know where I'm going to put it yet. There'll probably be some more fields. We'll figure it out. Okay, so this is this. So this is going to replace this. The ESB IRQ is going to be... You're probably going to get the... Who needs the timer? Who's actually using the timer? Reference timer. No one's using the timer. Timer init. So we init it in there. Who uses this timer? Transmit. Okay. Nope. I don't know who uses that timer. I'm going to assume the radio gets the timer. Let's just make that assumption. Trait implemented for the NRF timer peripherals. It does timer things. Timers interrupt fire after a given time in microseconds. Acknowledges the timer's interrupt. Returns whether a timer interrupt is currently pending. This must be called by the interrupt handler to avoid spurious timer events. Okay. So we've got a timer, I suppose. Seems nice to have. ESB timer. Okay. Well, let's say that the interrupt is going to have it right now. Timer, where timer, ESB timer, and I need to import that. Where does that get defined? ESB timer. Cool. Use peripherals. Unused import peripherals. Use crate peripherals. Timers for act timeouts and retransmitting windows. Yeah, I think the radio can totally own the timer. That's my thought right now. Let's see if I'm wrong. ESB timer cannot find the trait type. Oh right, timer. Cannot find ESB timer in this scope. Why not? Is there a struct called ESB timer? Struct ESB timer. You are a trait. Because we don't use the same camel casing rules. Probably got to fix that at some point. Okay. Okay, so we've got the timer. What else is being used here? What else does this radio have? TX buff, RX buff. Okay, we don't need that anymore. Lib radio. Oh, cool. ESB radio. So where are you, ESB radio? Because I probably need that. Okay. Radio, where radio is going to be ESB radio. Addresses, yeah, we're probably going to need that. State, where does state come from? Use crate packet addresses. Where does state? Use crate state mate. ESBIRQ radio is going to be a radio. We're going to have state is going to be state. Addresses are going to be addresses. And attempts are going to be U8. ESB radio. Did I not import that trait? Expected trait found. Oh, you're a struct. Interesting. Go to definition. Okay. I don't need the buffer anymore. Pack radio. Oh, that's interesting. Great. I'm going to have to wiggle this around a little bit, but you're actually not a trait. You're going to be a radio. because I'm making the ESB radio struct right now, basically. So radio, use crate per radio. Cannot find radio in this scope. That's fine. Okay, so I think I have all the stuff that was in there. And how do we pen the interrupt? It's probably just going to be like a radio : penned, but okay, well, we'll figure it out. Let's yeah, whatever. Is this using, do we release 09? Okay. You know what I'm going to do? I'm going to do cargo doc. And this might make my computer very sad while it goes to compile things. Yeah, I think that's what I need for this. Are you? That's good. It's caching some stuff. That's nice. Let's see. How's my stream doing? Radio is the struct from pack. ESB radio is a wrapper so I can put my methods. Okay. That's fine. But I think I'm just going to do that myself. ESB.radio.init. So what I probably should start doing is I should start making an application that starts doing this just so I can make it reasonable. But let's just start copying and pasting code. So ESB buffer. Okay, that's the other thing that I'm going to need. I'm going to need use core sync atomic bool. Pub. Oh, probably not pub, but whatever, pub. Already split is an atomic bool. Impl. Try split. Let's see, and these need to be to do mark as send. Well, I guess I probably don't. Actually, I don't need to do either of these because all of the components are sync or send. So I don't have to mark them because coherence, or not coherence, I don't remember what it is, but Rust is smart enough to realize that core, do we have an error type for the crate yet? Error, sure do. Already split. Do you have a result type? Nah, okay. Use core result. Where's my result? ESB app, ESB IR. See, am I immediately screwing things up with how I wrote? Nope, app. Okay, cool. Trust my gut. So you either get a tuple of handles or you get use crate error, or you get an error. No outgoing len in this scope. Result, parenthesized type parameters may only be used with fn trait. That's not even how syntax works. Number of type arguments. Oh goodness, you are going to be a large type signature. Expected 3. What's the third one? Third one's gonna be timer. So I'm gonna need all you two. Timer, sure. Timer, what did you? Timer. Cannot find timer in this scope. Unused import. ESB radio. What you mean? Oh, right. Timer. Expected 2, found 3. Expected 3, found 2. Nope. Cool. Sorting out generics like a pro. Okay. Okay, so try split. What am I gonna do? Now I need to do the splitty thing, which is this. So I don't need to assert in RAM because you can't make a BBQueue outside of RAM. ESB radio. I don't need the ESB radio stuff because that's just going to become a method of ESB IRQ. Right now, oh, this is fine. Okay, I'm going to have to make the ESB. So, okay, so let's leave that there. So let's do I need to do 2 splits. So I'm going to do self.app2radiobuff.try split framed dot map error map error. What is it going to be? It's going to be error already split, and then we do I guess we don't need the already split bool because I guess we already handle that. Because I guess we're already safe here. So, because if our underlying buffers have already been split, then we've already been split. So let A, B, these are terrible names. Yep, okay. ATR prod, ATR const, RTA prod. The problem with putting the timer on is that if it fails, you will lose the timer, but it doesn't seem that bad. It shouldn't fail anyway. I'll admit I don't understand that yet, but I'm sure I will once I actually start writing the code. So stick with me. I promise I will read that feedback again later when it will make more sense. Okay, so I have my consumers and producers and stuff like that. I'll have been given a timer. I'll need to have been given that's not how formatting works. Just for funsies, actually. Well, yeah. What are you complaining about? Oh. So done my splitsies. And I need to do my init with the addresses and stuff. We'll get to that. But for now, we also need a radio, which is a radio. What else do we need? We need our timer and we need our addresses. Addresses. Very verbose code. Okay, so let's app equals ESB app prod to radio equals ATR prod const from radio is going to be radio to app consumer. I think that's all we need actually, because you only have 2 items. Let IRQ equals ESB IRQ. You have a bunch more stuff, so I'm going to cheat. Let me go ahead and check chat just in case. Nope, no one's talking. You all are a quiet group in chat. Let me make sure it's because the stream's actually still running. Yes, stream is actually still running. There's 5 of you here. So hi to the 5 of you who are sticking around. You're the ones who actually get to see me code stuff. So prod to app is going to be radio to app producer const from radio consumer from radio. What? Consumer from radio. Oh, I screwed up. Prod to const from app. This is why descriptive names are helpful, because you keep yourself from making stupid app to radio consumer. Timer. Timer is actually just timer. Radio is just radio. State idle. Addresses is going to be just the one you gave me. And attempts is going to be 0. Let's just happy path return here. Okay. Okay. Cool. Cannot infer appropriate lifetime. Must be valid. I know why. Because I cheated and made... No? Is that not? Can I infer... lifetime cannot outlive the anonymous function lifetime defined in the method body in try-split. So the reference does not outlive borrowed content. So this expression is assignable because our frame producer, so our BBQueue has to be static. But the producer should have the same frame consumer has a lifetime. And the other thing I need to look at is just BBQueue. Did I screw up a lifetime somewhere? Try split framed. No. BBQueue of static lifetime will give you back a frame producer of static and that. So what am I not specifying that my BBQueue needs to also be static? Because I didn't tell it anywhere that my BBQueue is static. But I feel like I need to tell it that my BBQueue is static, because that's the only way that this works, is if the BB buffer is also static. But a BB buffer is... Yeah, okay. The whole thing has to be static. This seems odd. Yeah, so it's because... Yeah, the BB buffer doesn't actually have a lifetime, which means the lifetime of the actual object has to be static. So like to get a static one, it has to be the same lifetime as this, which makes sense because, yeah. So basically, yeah, that makes sense. So let's go see what the radio init to do. Set up radio to do. Set up timer. So I'll need to set up the timer and I'll need to set this. So let's... But those are going to be methods of the ESB IRQ. Impl. Why are you complaining? Probably because you're empty. Fun. Init timer. Doesn't look like you can fail, so... Just in case this needs to be called multiple times. Okay, so this actually isn't That doesn't need to be a method because that's just a trait method. No method. Oh. Set up the radio. Okay, so where does the radio init come from then? This looks like a radio init. Fun radio init. Okay, so I'm gonna pretty much wholesale steal this method and assume that Talus has figured this all out wonderfully. Well, let's just steal. Okay, init in the radio. You're big on safe, and then we also need stuff like this. Max payload. Okay, what are you going to complain about? Address conversion. Where are those handy helper functions? Definition. I'm gonna steal your functions because they're nice. Cannot find your constants. Gonna steal them too. Cool. So, doing some stuff. That's nice. Okay, so now we have that. So let's call where do you do what you do. M::U8 max payload. That's certainly a thing that you do. Oh, but that's fine. Because we can do that in the... Okay, yeah, we can do that. We still need the max payload. Cool. I'm not going to do it in the same way that you are. I'm actually going to expose this at the top level. So in our split, we're going to have another one that says max payload bytes is going to be a U8. And we're going to call IRQ.init radio. And I already have the addresses. You're not failable, are you? No, borrow of moved value addresses, because addresses is already... Does addresses actually need to live? Okay, I suppose. Init radio. Suppose you don't need it because I've created a struct that already contains it. So where is it going to yell at me for not have addresses? Cool. Cannot find value addresses. Cool. You're not really public, but hey. Start TX. That's probably something to note for my notes. Or do we want push? I'll tell you what. Let's too much time programming in C lately. I think I would like to keep the radio code separated because it can be a bit complex. Okay, I'd understand that. We can keep the radio. Well, maybe I'm going to disagree with you for now. I think you're probably right. It probably should be a separate item. But the reason that I'm not doing that right now is because I don't know what all the lifetime, or not lifetimes, but like what objects you need access to. But that's mostly because I don't understand when you need the timer and when you need stuff. So right now I have it all just in one big pile. But to be honest, you're probably right, and it probably will get cleaned up. But I'm going to leave it like it is right now, but probably not forever. So I'm going to admit you're probably right. Okay, I want to take another quick 5-minute break, and I'm going to come back, and hopefully I'm going to get this all building, and I can finish this up. I probably won't be able to test it on actual hardware today, but hopefully I'll have something that will build and Talis can start using, and hopefully doesn't immediately panic as soon as I actually run it. Maybe I'll run it on a radio just to see if it, like, sort of runs and does nothing, but we'll see. But I will be back in a couple minutes.
Honestly, I can't complain. Enjoy the mountains, watch the trains, but the cowbells are driving me insane. Jingle, jangle, oh, dingle, dangle. Cowbells are driving me insane. Jingle, jangle, oh, dingle, dangle. Cowbells are driving me insane.
Okay, so last stretch. I'll probably go at this for like another half hour. We'll see how long I get. Um, I see 6 people are still sticking around in the stream. So hey, say hey in chat if you're still around. Let me know if you're working on something. I like shouting out projects. So unfortunately, usually link pasting doesn't work. But if you send your GitHub username and a repo name or something like that, or a crate that I can look up, yeah, pasting links in the chat doesn't work. For some reason, it always gets filtered. If you know anything about YouTube, I'm a noob and I don't really know what I'm doing. So if you have something you want to share, something you're working on, I like showing other people's stuff off. So feel free to tweet at me or talk in Matrix or send me in the chat. Talis during the break has completely convinced me that I should just reuse the radio code. So I'm going to go refactor the radio code or the ESB radio so that I'm not copying and pasting code because he is very right. So let's go find our ESB radio. Where does ESB radio live? Definition. ESB radio. Get rid of generic stuff so it's just a wrapper struct. You don't need to exist anymore. You don't need to exist anymore. I'm going to get a lot of compilation errors probably because the buffers don't exist anymore. Wrong number of type arguments. Yeah, I know. So if you follow me on Twitter, I'm BitShiftMask on Twitter, and this is the joke behind my name on Twitter is that when I'm working on BBQueue, everything is lifetime static array length. So yeah, it's not a very good joke. It's just a transmit payload. See, this is gonna be different because it's gonna be a grant. What are you gonna be? You're gonna be a you're gonna be a frame grant R? Oh, is the lifetime gonna get infected? It probably is. And array length. You're just gonna be a U8. You're gonna be static. Basically everywhere I have static is gonna be wrong. BQ. Frame grant R. Wrong number of type arguments. Where lib line. Yeah, you're all wrong now. See, this is what I didn't want to deal with. But to be honest, I think I actually can just get rid of this now. I will need to move. Start TX is going to work a little different. Hey, Talus. Okay, well, I got you around. Let me finish. Oh, give me a second. Excuse me. Excuse me. I know I called you out and Talis, how do you feel about, so there's two kind of options here. So I can make it so that like when you push a message into the buffer, it immediately tells the radio to start sending it. This would be like auto send. So as soon as you push, basically like finishing the push, triggers the radio interrupt so that it starts going or triggers some kind of interrupt. The other option would be you could push and you could start TX separately, and it wouldn't immediately send. Do you have a preference, or do you think one of these would work better than the other? Because I don't know. Like, I can implement either of these. I just don't know which one is better. Like, would you ever want to have messages queued that you don't immediately send? I don't know. Maybe if you wanted to queue up a bunch of messages at the same time, but you could also, like, just start TX a bunch of times. And if a message was already, like, in progress, then that's fine. You'll get an extra interrupt, but you'll just ignore it or whatever because it'll say, nope, I'm busy. And it'll be smart enough to continue. I see you typing, so I'm going to sip on my beverage while I'm waiting for you. Yeah, so Talis is saying, yeah, we can do auto with the NVIC. Seems good. That way you wouldn't need to lock the ESB IRQ. Yeah, the plan for all of this is actually to have no mutexes. The goal is to have no critical sections or mutexes. The one thing that I haven't dealt with yet is if we want to actually support the NRF51. The NRF51 is a Cortex M0 Plus. So I'm going to need to use we're going to have to pass through the BBQueue feature for this. I haven't done that yet, so technically you wouldn't be able to implement this on an NRF51 right now, but the way to do this would be to do, let me, I'll just add a note. Optionally have the thumb v6 feature to support the NRF 51. Yeah, this will have a critical section in there, but it's going to be really tiny. I think even with the it shouldn't introduce that much jitter. It's going to be like 10 instructions or something in a critical section. So unfortunately, that's just the deal with BBQueue, is it requires a critical section. We should test it with an NRF 51. I have some somewhere here, so I can test it later. But I think for right now, getting the 832 and the 840 working, because I have an 832 and an 840 that I can test on. But yeah, we should try doing like a stress test on the 51 because it's Cortex M0 Plus. But yeah, the critical section in BBQueue is super small. Yeah, like I said, it's probably going to be something like 8 or 16 instructions or something like that in the worst case. Yeah, with the current state, we can probably figure it out. I agree with you on that. Let's do the auto send, and if someone ends up wanting the feature that's like, hey, I want to queue without sending automatically, then we'll implement it then. But otherwise, let's just get this going. Okay, what was I doing? I was going to, instead of just containing the radio, my ESB IRQ is going to contain instead an ESB radio. And I think that's in peripherals. So I think this transmit function is wrong now. Like the transmit function. Yeah, okay, you're right. You keep telling me to stop being lazy, and you're so right. And okay, there, I did it. You're right. That was much easier than I thought it was. Well, yeah. Yeah. Okay. Cool. So yeah, now it okay, now it supports the NRF 51. Cool. You're right. Yeah, that transmit function I think is gonna be wrong, but you know how we fix that? We fix that like this. So let's. Oh, this is in the ESB. Excuse me. Well, the ESB is going away, but yeah. Sorry, I should be in peripherals. Transmit. Okay, yeah. This is what it is. I can't fix the transmit function easily after. I can fix the transmit function easily after. Don't worry. Okay, yeah. So this is a frame grant R. So what I'm actually going to do is I'm just going to take ESB and you actually all go away now. Peripherals. Line 120. TX slice equals not deref mute. PID and no ACK. Okay, this is where the shenanigans is going to start getting shenanigansy. Okay, what was this type before? It was a payload. Okay, what does the payload look like? Packet payload. Right. So we actually need another type here, don't we? We need to wrap the grant that we give to the users to contain like the PID and NOAC and the pipe and stuff like that. Okay, that's what you were talking about. Now I'm following along. So I need to make another struct. Do I need... See, I'm going to need two things. I guess I'm going to end up having a grant R and a grant write. So let's say TX payload. Because I don't know where RSSI, like where do you use RSSI and stuff? Oh no. Okay, so you don't actually put RSSI anywhere. I'm worried that we're gonna have like 4 payload thingers. But I guess we'll get to that when we get to that. TX payload. Okay, let's just get this going. TX payload is going to contain some stuff. What does TX payload contain? TX payload is going to be array length U8. You're gonna have a pub PID and NOAC, which is a U8. You're gonna have a pub pipe, which is a U8, and you're gonna have a pub grant, which is a am I gonna have to do the trickery like I did? See, I wonder if I... Oh, I'm gonna have to do this in layers, I think. It can just be a struct tx payload grant w. It can be. I'm trying to think what I'm gonna have to do for I want to hide the PID and pipe from the user. So like the bytes that I use in the grant for that are going to need to be hidden. I guess I could just do deref and give you access to the slice. I guess that's probably the easiest. I can just impl deref directly on tx payload. Yeah, let's just do frame grant R or W. Yeah, I mean, like, technically, yeah, I guess I could, yeah, I see what you're saying. You're saying just put it in the right positions and don't duplicate the size. Yeah, that makes sense. Okay, I'm with you. I'm with you. Also a note, because you're watching this, everywhere where I'm putting static, we probably should have real lifetime parameters, but 99% of the time it's going to be static anyway, because that's really the only way to make DMA safe. But yeah, it's a hack, but a not that painful hack. And it makes sorting out these lifetime stuff a little easier. this goes away. And I guess all of this goes... Well, I'm going to need some stuff in here eventually, so I'll leave this. And you're probably going to complain because now all my types are not... You only need static for DMA if you want to do it really safe. You totally have non-static DMA. Just, if anyone ever mem forgets anything, then everything's going to go terrible. Oh, I'm making things worse when it comes to ESB radio. You can tell I'm fading a little bit. I'm going to try and get this to at least a compiling state before I sign off for the day. Hopefully so you don't have to like wade through all of my gross yeah. Okay, where's my peripherals? Where's my radio? Where's my init? Yeah, now I need to pass it addresses again. irq.radio.addresses addresses on... Oh, it's just... Is it gonna complain that I'm borrowed already? Peripherals 120, no TX buff. Okay, yeah, cool. Yeah, okay, we're back here. It's not actually gonna be a frame grantor. It's gonna be a TX payload. And I don't need the static anymore. And I am going to have to impl dref mute, which means I'm going to have to look up what the dref mute. Dref, which means I need to implement the dref trait. Use core ops dref mute impl dref for tx payload. What do you look like? Trait declaration. Type. Target is fun dref and self target. It's gonna be and self dot grant like everything but the first 2 bytes. Transmit until if ACK. Ugh. Let's see. Are you smart enough to figure that out? Associated type bounds are unstable. What? Okay. I know I do this in BBQueue, so let's just go look at com/JamesMunns/BBQueue. Where do I impl the dref trait? There's definitely something I'm not thinking of because dref. Oh, it's just DREF frame TX payload. Oh, and this is always static. That's fine. Wrong number of cool. Let's just copy and paste code like the cool kids. Okay, cool. You will also need a method on TX payload to get the whole thing with length and PID. Well, I guess you can just do TX payload 0. Yeah, it's going to be pub for right now. I'm going to do some ugly things just because I don't know what the interface needs to look like. I'm making things ugly and work rather than correct currently. See, I got pub grant, so you can just reach into the grant if you want, but like probably don't do that. Oh, you typed something and then it went away. I guess you deleted the message. Yeah. Okay. This is fine for now. Okay, let's go take another crack at this. So, I have a payload. Type equals len. Where does the... That's what DMA needs, the transmit function in this case. Okay. Okay, so payload. I'm gonna copy that because that is a useful. Okay, so DREF is actually gonna be per. So this isn't gonna be a magic number. This is gonna be. We gotta have one for the length. One for the PID NOAC, then the payload, then RSSI, then pipe. Okay, so equals self.grant.len. So this is the total len. Let payload len equals len minus 1 minus 1 minus 1 minus 1. So it's going to be 2 dot dot payload len plus 2. then let's just go ahead and impl payload. I'm trying to think whether it makes sense to have access or functions for this. It probably doesn't. It probably makes sense to have private methods. Fun set length. Well, that's always going to be, yeah. Per. Trying to think whether it makes sense to have getters and setters for all of this stuff. I probably could do it on the creation of the grant. Probably do it on the creation of the grant. So I'll set everything except for length, and then when you commit the grant, it will do that. Excuse me. Because this is only on the yeah, I'm gonna end up having 4 payload types because I need one for frame grant R and one for frame grant right. I guess RSSI is gonna be there anyway because it's gonna get put there. Tell us when you send the RSSI, is that do you need the RSSI byte on both sending and receiving? And I guess it's just like ignored on sending? Like, do I just need that as padding, basically? Because if so, then actually I don't need any accessor methods. This is just on like, well, I do so I don't need to leave space for it on receiving. I only need to leave space for it on sending? Or is the structure the same in both directions and it just ignores it on the way out? But how does it? So you said it doesn't matter if it's in there or not. Oh, you're saying that the DMA doesn't care about the pipe. That's something that our actual radio, like the software, has to shove the pipe into the register. Okay, so I won't put the RSI on the outgoing. Okay, thank you. So the pipe needs to be there because DMA. Got it. Got it. Got it. Got it. Got it. Got it. Now I understand. Thank you very much, Talis. Now it makes sense. So I only need. So this is actually not gonna look like this. This is gonna look like this, where where this is actual DMA part, and this is for software use. We need a place to pass it back to the user. We're gonna end up having to have multiple types here, just because like grant R, grant W on both sides. I guess, okay, yeah, I see what you're saying. I could use one TX payload and one RX payload. Yeah, so this is actually going to be more like payload W. Payload W. Okay. Yeah. Okay. So what was that? What did I pull off? I pulled off the RSSI. Okay, yeah. So this is software use, and this is the actual DMA part. Let me know if this looks right to you, Talis. So length, PID-NOAC, and payload is what the DMA actually pays attention to. And then we just need to pass it back. So the RSSI and pipe need to be 2 bytes. Okay. Okay. Let's just put this in there. Doesn't mean anything when sending, only when receiving. And the pipe we do need. Okay, so raw grant length gets written on commit. So PID no ACK. So grant view multiple raw access balance checking. PID grant 1 raw grant 1 equals PID no ACK raw like the pipe gets written at the end too, so like you actually don't know what the pipe is gonna be. The pipe gets written at the end, which is sort of a weird, I guess, in just your send call. Wait, how does PID no ACK? So when you receive a packet, the DMA actually writes the PID no ACK field? Okay, you know what? I am going to commit what I have. I think I'm git add minus I, checkout minus B. Almost working. Still need to mess with the grant. Yeah, I think it might make sense to put all of those in the beginning just because we don't know the length and stuff like that. Still need to mess with the grant interfaces. So what I actually need to do is go to office hours and go to your repo and actually fork this repo. Thank you for all your help, Talus. This has been super helpful. Yeah, feel free to if you want to like merge this and keep working on it, you're welcome to. I'll mark it as ready for review just so you can merge it if you'd like. I think usually I allow contributors to allow edits from maintainers. Okay. So you can edit this, you can like push to it and stuff if you want. But it's 1:10 a.m. here in Germany, so I'm gonna call it for the night. I'll pick this up back maybe tomorrow, maybe Wednesday. I'm not 100% sure whether I'm gonna stream tomorrow, but I'll keep working on this. It seems like we're making good progress. Most of it makes sense. It's just figuring out some of the details because we're reorganizing some of the data structures. So I guess I'm not writing that RFC tonight, but I said I would do it for the next meeting, so I'll have to do that during the day tomorrow. So maybe I'll wake up a little early tomorrow. But yeah, let's see. Do we have anyone other than Talus still watching? Whew, Carlos, you have a big question right before the end of the stream. Carlos, you're asking about unit tests. In a recent Q&A, I can't remember which one. If you go and look on the Ferris Systems YouTube, there's 2 Q&As. Unfortunately, I can't remember which of the 2 it was. I gave a way longer answer about that. Let's see if I can... notes. BRP next step testing. Okay, yeah. Okay, so it was in the first one and it's going to be kind of later. So let me youtube.com/c/Ferris Systems GmbH. In the first one, Rust Embedded Mentoring, like somewhere in here, like an hour and 15 minutes in, I give a way longer answer about hey, I'm wearing the same, no, it's a different sweater. I give a way longer answer about testing. The answer is It doesn't help you for running unit tests on your hardware right now, the part that's built into the Rust language, but you can run unit tests for common stuff off of your target, particularly if you have a no standard crate. And there's some other tools that make it possible to run more unit tests. So Carlos, it's very late for me, so I won't be answering that today, but I would go, let me show you that again. That's on the Ferris Systems YouTube channel. There's a Q&A playlist. And for the one from April 1st, there is an answer to that question about an hour and 20 minutes in. And I gave like a 15, 20-minute answer on that. So hopefully that answers your question. Otherwise, hit me up on Matrix or Twitter or email or something like that. And I'm happy to help you through that. But yeah, let's see. Yeah, I guess there's at least 2 people still around, so that's good. I got 7 people. Wow. Viewership is going up. Okay, well, thank you everyone who watched. I'll do like a stream summary, but the answer is like this pull request is what was worked on for the last 2 hours. So I really appreciate everyone watching. Keep an eye out on my Twitter, subscribe to the YouTube if you would like to know when I'm going to stream next. It'll probably be tomorrow or Wednesday. Tomorrow's the embedded working group meeting, so if you're watching this, I'll probably at 8 o'clock be in the embedded working group meeting, and I'll see how I'm feeling afterwards. Probably I'll make a call around 9 o'clock whether I'm going to stream or not. But if I do, it'll be about 10:30, about the same time I started today. So thank you all so much for watching. Thank you especially to Talis Fregoso, who both wrote the beginning of this repo and has hand guided me through how the entire code and how the radio actually works. So I really appreciate you going out and doing all of the radio research that I was too lazy to. So I super appreciate that. Go ahead and star and watch Talis's repo. I think this is going to be a really cool thing. I can't wait until this actually works because I want to build some really cool stuff with like postcard on top of this and make it just stupid easy to send. Like, my goal is that you can wirelessly send structs and that, like, you don't even have to think about what the interface is going to be. You just use postcard to, like, magically send structs from one device to another at 2 megabit per second, which is just silly fast. And then in the future, I also want to build some stuff like cryptography signing and maybe even encryption on top of that. So you can also have, like, signed and encrypted messages over the air. And then even maybe build something silly like being able to break up messages so you can send messages that are larger than 255 bytes. But got to get this working first. So huge thanks again to Talis. Thank you to everyone who watched. If you want commercial help, come check us out at Ferris Systems. I'm too tired to do the full plug. So thanks everyone who watched. I'm going to wrap up for the night, and I will see you later this week, either tomorrow or Wednesday. Bye, everyone.